Hello everyone, welcome to this session. Our chapter is motion in straight line. So far in our previous video, we discussed the velocity time graph. We saw how you can calculate the distance, how you can observe it, this velocity time graph. So today, let's move on to the other part where we'll be discussing about the equations of the uniformly accelerated motion. So we'll see various equations that are used to a body that moves in or the body that is in motion. So specifically, we will discuss equations of motion. Now, the motion of any body in a straight line, it can be described by using these three equations, which are generally known as the equations of motions. So we'll see that all these three equations are there for a body that is in motion that moves in a straight line, and as we said that all the three, they can be described as equations of motions. So we'll start with the first one, that is the first equation of motion. Consider a body that is initially moving with the initial velocity denoted as u, and after a certain time t, it accelerates to the final velocity, that is v. Now for this kind of a case, here's what happens. We know that acceleration is equal to change in velocity over time, so we'll be equal to final velocity minus initial velocity over time. Now if you cross multiplication, a times t equals to v minus u. Now if you make v the subject of this equation here, so it will be equal to v equals to u plus at. Now this is what we call the first equation of motion. So the first equation of motion, it can be obtained in this kind of a way when you are trying to find acceleration by taking the change in the velocity over time, that is final velocity minus initial velocity over time taken. So that's clear. So that's the first equation of motion. Moving on, the second equation of motion. Consider a body moving with the uniform acceleration. Now its average velocity, it can be obtained as follows. So average velocity, we know that equals to displacement over total time taken. Now v will be equal to this displacement can be denoted by s, so will be equal to s over time. Now average velocity will be equal to displacement. It means that the initial velocity plus the final velocity. Yes, you get to understand the displacement taken over 2. Now if you take like this, so the average velocity also will be equal to s over time. Now if you cross multiplication, you try to make s the subject, so s will be equal to u plus v over 2 times t. So s is equal to u plus v in brackets times t over 2. Now, but we know that v is equal to u plus at according to the first equation of motion. So this is how you can get the second equation of motion. I hope that's clear. Therefore, for this way, s will be equal to u plus u at in bracket times time over 2. So u plus at in bracket t over 2. Now, this, if you add these two u's to be 2u plus at in bracket t over 2. So s will be equal to 2u plus at square over 2. Now, if you continue here, as you add this later on, you get the answer, that is u plus half at square. So this is the general second equation of motion, s representing the displacement. So s is equal to u plus half at square. I hope that's clear. So this is the second equation of motion. Moving on, the third equation of motion. The third equation of motion, it can be obtained by squaring the first equations on both sides. So you can obtain the third equation of motion by simply squaring the first equation on both sides. Now that can happen as follows. We know that v is equal to u plus at. Now if you square both sides, you get v squared is equal to u plus half at in bracket square. So the answer from here, you get v square, you square it means if we expand this one, will be equal to u plus 80 in bracket plus in bracket u plus 80. So v square will be equal to u square plus 2u80 plus a square t square. So we get v square is equal to u square plus 2a in bracket ut plus half at square. But we know that s is the value of this ut plus half at square from the second equation which we saw. So generally, therefore, will be equal to v square is equal to u square plus 2as. So that is finally the third equation of motion. Now all these three equations, they can be used in various places. So here we see that the equations of accelerated motion in daily life. So we can simply use these equations of motion in our daily life, but the three equations, they can be used to solve many problems regarding the motion of different bodies. Now here are the examples. We'll start with the example 1. An object moves at 20 meter per second due north at an acceleration of 2 meter per second square. What will be its final velocity after it has moved 21 meter? Now the solution is as follows. Given that the initial velocity we know that is 20 meter per second from the example given, acceleration is 2 meter per second square. Distance s we know we given is 21 meter. Now the final velocity, it can be obtained by simply using the third equation of motion, where you take v squared is equal to u squared plus 2as. So you can simply use any of these three equations which you have seen by simply knowing what you are given to the example or to the problem which you have. As in this case, for this example, we have the initial velocity, acceleration, and the distance. So we use the third equation of motion. So v squared is equal to u squared plus 2as. V squared will be equal to 20 squared plus 2 times 2 times 21. Now we get the answer. V squared is equal to 400 plus 84. V squared is equal to 484. Now if you square root both sides, you get the answer, that is 22 meter per second. So the final velocity will be 22 meter per second. Hope that's clear with this example. Moving on, another example. An object traveling at 12 meter per second accelerates at 4 meter per second square for 16 seconds. Now we are required to calculate the final velocity and how far does it travel for 16 seconds. Now here the solution. Given that we know initial velocity from the example, initial velocity equals to 12 meter per second, acceleration is equal to 4 meter per second square, time taken is 16 seconds. Now the final velocity, it can be obtained simply by using the first equation, that is v equal to u plus 80. So v will be equal to 12 plus 4 times 16, that is, we get the answer 12 plus 64, that is 76 meter per second square. 76 meter per second. Now the final velocity is 76 meter per second. Now the distance traveled s in 16 seconds. This can be obtained by simply using the second equation of motion. S is equal to ut plus half 80 square. So s will be equal to 12 times 16 plus half times 4 times 16 square. So we get the answer here, that is 192 plus half 4 times the square of 16 is 256. So s will be equal to 192 plus 512. Now s will be equal to 704 meter. So the object traveled as far as 704 meter in 16 seconds. So that's all I have for this session. I hope that's all clear. Thank you guys for listening. We've seen the different equations of motion. We've seen the first equation, the second equation, the third equation, how you can obtain them, and we've seen some examples concerning using these equations of motion. I hope that's all clear, and thank you.